All right, everybody, and that is a few useful string methods that you may be interested in. Hey everybody, in this topic I'm going to explain string indexing. Indexing allows us to access the elements of a sequence using a set of square brackets, also known as the indexing operator. Using this set of square brackets, following a string, there are up to 3 fields that we can fill in. We can access a starting point in the string, an ending point, and a step. Here's an example. Suppose we have a credit card number. Credit number equals, and I'll just make up some number, 1234-5678-9012-3456. Good enough. If I need the first character within the string, I can type the name of my string variable, followed by the indexing operator, which is a set of square brackets. The first position has an index of 0. Computers always start with 0, so that's why the first index is 0. Then I'm going to go ahead and print this. Print credit card number at index of 0. That would be 1. If I were to change the index to be 1, 0, 1. That should be 2. Index 2 would technically be 3. Then 4 is the dash within our string, as you can see here. With the indexing operator, there's up to 3 fields that we can fill in. A start and a step. If you have just one field listed without any colons, it's assumed you're filling in the starting position. So now what if you would like the first 4 digits of the string? Well, we would type the name of our string variable, indexing operator. We'll need a starting index, colon, then an ending index. The first 4 digits would be 0, colon, 4. Then I will print this. And I'm just going to turn this first line into a comment. Yeah, there we go. We have the first 4 digits of our credit card number. 1, 2, 3, 4. Just so you know, with the ending index, this index is exclusive. This first number would be 0, 1, 2, 3, 4. So we did not include that dash within the number. The starting index is inclusive. The ending index is exclusive. So you can omit the 0 in the beginning. You could just say colon 4. Python assumes the starting position will be the beginning of the string. So that would work too. Let's get the next set of digits, 5, 6, 7, 8. Credit number, indexing operator. Let's find where the starting index would be. 0, 1, 2, 3, 4, 5. 5, colon, 6, 7, 8, 9. Then we will print whatever is here. The next set of digits is 5, 6, 7, 8. Maybe we need the last 12 digits. Well, what we could do in that case, we will take our string variable, credit number, set the starting index to be, let's see, 0, 1, 2, 3, 4, 5. 5, colon. If you need everything up to the end of the string, you don't need to list an ending index, just be sure to add that colon. Python then assumes you need everything up to the end of the string. So I will print whatever we have. Then we should have everything besides the first 4 digits. Yep, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6. You could also use a negative index. Credit number. If you need the last character in a string, you would set the index to be -1. Then I will print this. Print credit number at index of -1. That would be 6. -2 is 5. -3 is 4. -4 is 3. And then -5 would be that dash right here. Yeah, you can use negative indexes too. Let's talk about step. Using the step field, we can access the characters in a string by a given step. We can count by 2s, or we can count by 3s. So here's an example. So let's take our credit number. If we're not filling in the starting or ending fields, but we need a step, we would need 2 colons then. Python is assuming everything from the beginning of the string to the end then. Our step will be 2. This will print every second character within our string. Yeah, here we are. We have 1, 3, dash, 6, 8, 9, 1, so on and so forth. If I were to change the step to 3, we would count every third character, beginning with 1, 4, 6, dash, 1, 3, 6. All right, here's a practical example. Let's create a program to get the last 4 digits of a credit card number. I'm going to assign this to a new variable. Last digits equals our credit number, indexing operator. So we need the last 4 digits. Where would the starting index begin? Well, we could use negative indexing. This last digit is -1, -2, -3, -4. We will begin at -4. Colon. We can omit the ending index. Python assumes we need the rest of the string then. Really, that's all we need. So let's print. I'll use an F string. Maybe some X's. Maybe we're hiding somebody's credit card number except the last 4 digits. Okay, then variable last digits. All right, and here's our credit card number where only the last 4 digits are visible. Hey, you know what? Let's add one more exercise. Let's reverse the characters in the string. I'm going to reassign credit number equals credit number. If we need the entire string, we don't necessarily need a starting index or an ending index. But for the step, this will be negative. -1 will reverse a string. Then let's print whatever our new credit card number is. Print credit number. And yeah, there is our credit number backwards. To reverse a string, you set the step to be -1. So yeah, everybody, that is string indexing in Python. We can access elements of a sequence using the indexing operator, which is a set of straight brackets. You can list a starting position, ending position, and even a step if you need to skip over characters. But yeah, that is string indexing in Python. Hey everybody, in this topic I'm going to explain format specifiers. Format specifiers specifiers, when used in the context of an F string, they allow us to format a value. Specifiers, when used in the context of an F string, they allow us to format a value based on what flags are inserted. Following your value, you would type a colon and then some flags. Depending on what flags you insert, it will format your output a certain way. You could add decimal point precision, allocate space, zero pad values, left justify, right justify, center align, all sorts of things. Let's have some practice. I'll create 3 prices. Price 1, price 2, price 3. Price 1 will be 3.14159. These values aren't in dollars and cents yet, but they will be. Price 2 will be negative 987.65. As you can see, I'm just making up numbers here. Price 3 is 12.34. Let's display our prices using some F strings. Price 1 is placeholder price 1. Then we will do this for price 2 and price 3. Price 2 is price 2. Price 3 is price 3. Within our placeholder, following the value, we can add a colon, then some flags. Those flags are the format specifiers. They will format our value a particular way depending on what we insert after the colon. To add decimal point precision, you would type, after the colon, dot, then the amount of decimals to be displayed, maybe 2, then F meaning floating point number. Let's do that with price 2 and price 3. Colon, dot, 2, F. Price 1 is now 3.14. Price 2 is negative 987.65. Price 3 is 12.34. I think I'm going to add some dollar signs before the placeholder. Yeah, that's much better. For less precision, maybe 1 decimal place, you can change the 2 to a 1. So 0.1F. Each number only displays 1 decimal, 0.1, 0.6, 0.3. Whereas in 0.3F would display 3 decimal places, 0.142, 0.650, 0.340. Even though price 2 and price 3 only have 2 decimal places in the original numbers, we will concatenate some additional zeros. To allocate space to display a value, after the colon, add some number for that many spaces. How about 10? Each value now has a total of 10 spaces to display the output. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you were to precede a number with 0, well, these numbers would be 0 padded. Each number is now 0 padded. To left justify a value, you would use a left angle bracket. All these numbers are now left justified. Then we have all of the space after. They're all uniform. Right justify would be a right angle bracket. And I believe that's the default. Center align, I believe, is the caret symbol. Yep, our numbers are now centered. If you have any positive values, and you would like to display a plus sign, just use plus. Any positive number is preceded with the plus sign, any negative number is preceded with the negative sign. Or you could use a space for any positive numbers. So colon, space. These numbers are lined up evenly, even though we have a negative number in here. There is a thousandth separator, which is a comma. We should probably increase the value of our prices. 3,000, negative 9,870, 1,200. Each thousandths place is now separated with a comma. We could also mix and match flags. I would like a thousandth separator, along with decimal point precision of 2 decimal places. And why not? I will precede each number with a plus sign if it's positive. Yep, here we are. So based on what you're looking for, you can add some combination of flags. So yeah, those are format specifiers, everybody. Within your placeholder, insert your value, a colon, then certain flags based on what you're looking for exactly. But yeah, those are just a few format specifiers in Python. Hey everybody, in this topic, I'm going to explain while loops. A while loop will execute some code while some condition remains true. Here's an example. We'll use an if statement first. We will ask a user for their name. Name equals input. Enter your name. If our name is equal to an empty string, that means the user didn't type in anything. Let's print a message. You did not enter your name. Else, we will print, using an F string, hello, our user's name. If I were to skip this prompt, we would execute this if statement, then we continue with the rest of the program. What if I would like to continually prompt the user to type in their name? We can't continue until they type in something. Well, we could replace this if statement with a while loop. While this condition is true, continue to execute this code. Within the while loop, I'm going to reprompt the user to type in a name. Then if we were to exit the while loop, then we will print hello, whatever your name is. So let's run this. Enter your name. I'm going to hit enter. You did not enter your name. Enter your name. No, no, no. Okay, I give up. I'll type in my first name, hit enter. Hello, whatever your first name is. While this condition remains true, execute this code potentially forever until this condition is no longer true. So that's one of the main benefits of a while loop. If it's not true, then you exit out of the while loop. And that's why we were able to continue, then print our name. Hello, name. You do want some way to escape out of the while loop, otherwise you'll run into what's known as an infinite loop. So let's say while name is equal to an empty string, we will print you did not enter your name. So I'm going to hit enter. So we are stuck in an infinite loop. We can't actually escape this loop. We didn't give ourselves an exit strategy. That's why previously we reprompted the user to type in something. We're giving them a chance to escape. In a way, it kind of works like an if statement, but instead of executing some code once, it's potentially infinite. Here's another example. This time, let's ask for a user's age. Age equals, and I will convert the input to an integer. Enter your age. We'll need the user to type in a positive number. While age is less than 0, let's print a message to let the user know that they can't do that. Age can't be negative. Then we need some strategy to escape. Let's reprompt the user to enter in their age. Once they type in something that's valid, we can escape out of the while loop. So let's print, using an f string, you are age years old. So enter your age. I'm going to say -1. Age can't be negative. -2. -1 million. Okay, I give up. How about 21? You are 21 years old. So that was another example. While our age variable is less than 0, repeat this code forever. Let's go over example 3. I'm going to introduce some logical operators. We will have the user type in a food they like. Food equals input, enter a food you like. But in order to escape, they need to press Q to quit. While food is equal to the letter Q, continue this while loop. However, I'm going to make one change. We want to exit the while loop when they press Q. So you could say while not food equals Q. So within this while loop, let's print the food that they stated that they like. I'll use an f string. You like your variable food. Then we will prompt the user to enter in another food that they like. Enter another food you like, Q to quit. Then once we escape the while loop, we will print just buy. Okay, enter a food you like, Q to quit. I like pizza. You like pizza. I like sushi. You like sushi. I like ramen. You like ramen. Okay, this program's kind of lame, so I'm going to press Q to quit, and we escape the while loop. We have printed by. So you could do something while something is not true by using the not logical operator. All right, last example, example 4. We will use the OR logical operator. We'll ask a user to type in a number between 1 and 10. Let's say num equals input. Enter a number between 1 through 10. Then I will typecast the input as an integer. While our number is less than 1, or our number is greater than 10, let's reprompt the user. Let's print, using an F string, our variable num is not valid. Then we will reprompt the user. Enter a number between 1 and 10. Once we escape the while loop, then we will print our number. Using an F string, your number is our variable num. Enter a number between 1 through 10. 0. 0 is not valid. -1. 100. Nope. 5. Your number is 5. That's an example of how you can add logical operators to while loops. While this condition is true, or this condition is true, execute this code forever. All right, everybody, so those are while loops. A while loop will execute some code while some condition remains true. It's fairly useful for verifying user input. If a user types in some input that is not valid, you can reprompt them. And there's many other uses that we'll discuss in the future. But yeah, those are while loops in Python.